All right, so here a couple people said divide by 3. So you can factor out a 3. That means the 3 comes from the outside. It's one of the factors. 3a squared divided by 3 leaves you with a squared minus 48 divided by 3. What is that? 16. And this is the difference of two perfect squares, right? Because a squared, if I took the square root, I would get a. And if I took the square root of 16, I would get 4, right? So two perfect squares, a squared minus b squared, factors always to a plus b times a minus b. And we know what we know what a and b are. Good. Again, interrupt me. Oh, good. Interrupt me if you have questions. But yeah. All right, here it's asking you to use the completing the square method. I wouldn't even waste my time, okay? If you don't want to. So instead, I'm just going to put it into standard form. So now it's x squared plus 2x minus 80. There's nothing on this side, so that's standard form. Now you can just use, it needs to multiply to equal negative 80. And it needs to add to equal 2. All right, this is a perfectly valid way to solve this one. You don't need to complete the square. Okay, I just wanted to go over that. And now back to, so that would be, and then you would be factoring it. So that way you would get 2 factors, and then you would solve both of those binomials for x. However, we were back on the quadratic formula. For the quadratic formula, we got, for this first one, we got very complex numbers, and then we skipped down to this one and we got no solution because we had a square root. What we had was 1 plus or minus the square root of negative, it was 1 minus 48, 47 over 8, right? And basically, until today's lesson, you cannot do that, right? There are no real number solutions if you're going to put a negative under an even root. So let's do these two, and then we will go on to imaginary numbers. So we'll call this 1, 2, 3 is 25 over 2x squared minus 20x plus 8 is 0. Again, we just want to find, because we're only doing the quadratic formula, we just want to find a, b, and c. A is 25 over 2. I would kind of, since we're just plugging it into an equation, you can change it to a decimal because it's just 12.5, right? Because 24 divided by 2 is 12, and then you're left with 1 over 2, which is 1/2. B is negative 20, and C is a positive 8. So we're just going to plug those in as we were doing last week. X is equal to negative 20 plus or minus the square root of, negative 20 squared minus 4 times 12.5 times 8. That's okay. All right. Thanks for telling me. And then on the bottom, you have 2 times a, and our a was 12.5. So 2 times a positive 12.5. And then we're just going to solve for that. X is 20 plus or minus negative 20 squared is 400. And then 12.5 times 8 is 100. So that's 400 minus 400 all over 12.5 times 2. 12 times 2 is 24. 1/2 times 2 is 1, so that's 25, right? So 400 minus 400 is 0. The square root of 0 is 0, right? So now we just have, sorry, a negative becomes a positive. So now we have 20 over 25 because 20 plus 0 is 20, 20 minus 0 is 20. Good. I can divide them both by 5. 20 by 5 is 4. 25 by 5 is 5. So this is one way that you get only one answer for x. Here we got one answer. Here we got no answers. Over here, if you remember, we got 2 answers. And then number 4 is weird one. We have 1 plus we have 8 over x. That's not usually where x is in a fraction, is it? Plus 7 over x squared equals 0. Well, it's in standard form, but I do want to get rid of the fractions, right? So the least common denominator for my 2 denominators, x and x squared, is going to be x squared, right? So my least common denominator for getting rid of these fractions is x squared. That means I need to multiply this, and this by x squared. And technically that side, but there's nothing on that side. 0 times x squared is still 0. So we'll say 1 times x squared plus 8 over x times x squared plus 7 over x squared times x squared. Now remember, when you're multiplying, it's the same when you're multiplying by a fraction and you just have one term, it's the same as that being in the top, right? If I wanted to multiply those by fractions and I didn't know what to do, I can make them into fractions. 1 times x squared becomes x squared. 8, that would be plus 8x squared divided by x, but x squared divided by x just becomes x, right? Everybody okay with that? Stop me if you're not. 7 times x squared divided by x squared is just 7. Now you can put this into the quadratic formula, right? But it kind of looks factorable. Those look like nice numbers. So I would need to multiply to equal 7, add to equal 8, right? And there's only 2 factors of 7 that are positive. 1 and 7, those do add to 8. So you can just call this x plus 7 times x plus 1 equals 0. Here, x, remember, your answer is not x equals 7. It's x equals -7, x equals -1. If you put all of that into the quadratic formula after you found a whole number for a, b, and c, it would give you that same answer. Those 2 answers. Any questions about quadratic formula? Oh, sorry, there's one more word problem. A ball is thrown vertically upward from the top of a building 96 feet tall with an initial velocity of 80 feet per second. The distance in feet of the ball from the ground after t seconds is s equals -16t squared plus 80t plus 96. The distance s in feet, or the distance height in feet, right? So the height is 16 times the time squared plus 80 times that time plus 96. Good. How many seconds does it take the ball to hit the ground? So what are they asking? Here's my building. Here's the ground. right? So I'm going to launch the ball. It's going to go up and it's going to go down. This is represented by a curve. And so if you put this into a calculator, a graphing calculator, or if you graphed it, it would be that same shape. So that's why this formula is quadratic, because when you throw a ball, it makes a curve until it hits the ground, right? So the distance in feet or the height in feet is this, okay? How many seconds does it take the ball to hit the ground? The t are the seconds. T seconds. Good. So the height is negative 16 times the seconds squared plus 80 times the seconds plus 96. So what is the height when it hits the ground? The height is 0, right? So what they're asking is negative 16 t squared plus 80t plus 96 equals 0. What is the time, right? In seconds. So you could change those to s's if you wanted. Can I divide? So I'm basically just factoring this. If I can't factor it, I could put it in the quadratic formula. But what can I divide all three of these by? I think I can divide them by negative 16. I want to divide them by a negative because you don't want that first term a negative if you're factoring, right? If it's t squared, you want them both to be positive t's down here. So negative 16 divided by negative 16 is just t squared, or 1. 80 divided by negative 16 is negative 5. And then 96 divided by negative 16 is negative 6. Good. Now we're going to try to turn those into two binomials instead of one trinomial. So t squared, the factors are t and t. Negative 6, so the two terms need to multiply to negative 6, add to negative 5. So I'm going to say t minus 6, t plus 1, because negative 6 times a positive 1 is a negative 6. Negative 6 plus 1 is negative 5. That means t minus 6 is 0, and t plus 1 is 0. T is 6. T is negative 1. So here I had two answers. However, how many seconds does it take the ball to hit the ground? Probably 6 seconds, right? Not negative 1 seconds. Negative 1 would be this side of the parabola before you threw it, because you threw it from up here. And then 6 would be when it landed. Here we have the same question for B, so that was A. For B, our question was, how many seconds will the ball pass the top of the building on its way down? So instead of a height of 0, they're asking us about this height, where you started. Here the height is 96, right? I threw it from a height of 96. How long until it is at 96 again? So that same equation, negative 16 seconds squared plus 80 seconds plus 96 equals 96, right? When will it touch 96 feet high? I want to set this equal to 0, put it in standard form, so I'll subtract the 96. Now it's negative 16t squared plus 80t equals 0. Good. All right, you could put this into your quadratic formula, but you could instead just factor out a term. What's the biggest term we can factor out? Negative 16t. Is that okay? All right, so now I have negative 16t Negative 16t squared divided by negative 16 is just t. 80 divided by negative 16, we already decided was a negative 5. That's still set equal to 0. So now I have negative 16t equals 0, and I have t minus 5 equals 0. Because remember, the reason factoring works is because this is a, and this term is b. If a times b equals 0, I can say that a is 0, or I can say b is 0. Even if my a doesn't have a plus or a minus, it's still being multiplied by b. If I multiply them together, they're 0. We can assume that they both could be 0. So here, negative 16t equals 0, divide by negative 16, divide by negative 16. 0 divided by negative 16 is just 0. Here, I'll add 5 to both sides. T is 5. How many seconds will the ball take to pass the top of the building on its way down? 5 seconds. So it takes 6 seconds to hit the ground. It takes 5 seconds to almost hit the ground. The equivalent of where I started. Right, so we saw that that second example when I put it all into the quadratic formula was no solution because if you have a negative under an even root or an even index, that becomes an imaginary number. Good. This is now going to talk us through what to do if you want to continue working on that problem. So we had the square root of negative 47, and we didn't want to just stop there. We wanted to keep going. So with linear equations, 1.1 was linear equations, right? Linear, x is raised to a single power. So we have 2x plus 1, something like that. Good. Quadratic, it's being raised to the second power. So we have x squared plus x plus 1, right? Here, you're going to find one solution. Here, you could find 2 solutions, right? Or you can find no solutions. Or you could find 1 solution. We saw all of those examples, right? We had to stop working if we found a negative number under a radical because there's no real way to take the square root of a negative number. If you're squaring a number, that number can't be negative, right? You stop, you say there's no solution to that problem. Unless you want to use the imaginary unit. The imaginary unit is I, and it represents the square root of negative 1. Good. It's like how in algebra, if you have a problem and you don't know the number to put into that problem, but you still want the presence of the number there, you just pick a letter, right? Or probably x, right? So we call that a variable. So you're doing math, right? Before you get to algebra, you're doing math, and then you come up with you want to represent a number and you don't know what that number is, you use a variable. Now we're doing math, we see this, and we want to represent that with a unit and continue working until we get the problem solved. When you are working with complex numbers, I is the square root of negative 1. So if you take that and square it, right? I is the square root of negative 1. If those are equal, then I can square them, right? I squared becomes I squared. The square root of negative 1 just means you lose the square root because the square root and the squared symbol are the same. Or sorry, are definitely not the same. They're inverse operations. They do the opposite, right? So I squared is negative 1. When that imaginary unit I is grouped with Real numbers, we call those complex numbers. It's written a plus bi. Good. The real number is in front. The complex number is in, the imaginary number is in the back. That is the standard form. Okay. To combine complex numbers, combine the real parts and the imaginary parts together, just like they're like terms, as though it was any other letter. You can add complex numbers, you can subtract them, you can multiply them, you can divide them. Okay. So we are learning this so that we can continue problems that you thought you had to stop because of a negative under an even radical. Good. Here we have the complex number 4 plus 6i plus the complex number -1 plus 2i. Good. Here is the real part. Here is the imaginary part. Combine the real parts as though they were like terms. Combine the imaginary parts as though they were like terms. Good. You can, in this case, you can treat I like a variable. So we're just adding, I'll rewrite it, 4 plus 6i plus, ooh, I should write that -1 plus 2i. Write it again. 4 plus 6i minus 1 plus 2i. And again, just combine like terms. 4 minus 1, 6 and 2. 4 minus 1 becomes 3. 6 plus 2 is 8. Looks the same over here, but you have a minus sign. So we're going to first distribute the minus sign. So you're not multiplying anything, you're just combining like terms. Well, you are multiplying because we have to distribute this, but we're not multiplying the 4 times the 1 yet and the 6 times the 2 yet. Negative, the negative value of -1 is +1. The negative value of positive 2i is minus 2i. Good? All right. 4 plus 1 now. 6 minus 2 now. 4 plus 1 is 5. 6 minus 2 is 4. Any questions? So you're just treating it like a variable, combining like terms. Always leave them in a plus bi form, because that is standard form. Real number in the front, imaginary number in the back. Multiplying complex numbers. So remember, for this, the information that we know is that I is what we use for a -1 under the square root. I was going to say a even radical, but it's the square root. So I squared, you can replace with a -1. Anytime you have an I squared, you can replace that value with a -1. Now we're multiplying them using the distributive property. 2i times 2i is just like any other variable. Multiply the numbers in front. 2 times 2 is 4. Multiply the variables. I times I is I squared, right? But we said I squared is -1, right? Everybody okay with how I got I times I is I squared? The rule for exponents is that when you multiply the exponents, keep the base, add the exponents. So this was I to the first power times I to the first power. We keep the base, we add the exponents. 1 plus 1 is 2. Because of that rule. So I times I becomes I squared. I squared we know is -1. So 4 times I squared is the same as 4 times -1, which is -4. Here, here, I hope you're thinking of two binomials and what we always do with two binomials, which is FOIL them, right? So we have 6 plus 5i times the quantity 3 plus 7i. First would be 6 times 3. 6 times 3 is 18. Outside, 6 times 7 is 42. There's one I. It's a positive, so I'm going to add them. Inside, 5 times 3 is 15 with one I. Still positive. I guess all these terms are positive, so everything's going to be positive. And then our last term is 5i times 7i. 5 times 7 is 35, right? And then I times I is I squared. I squared can be replaced with -1. Now I have 18 plus 42i plus 15i. Remember, don't write everything I write if you don't need to. If you are seeing what is a way to simplify this faster than I am simplifying it, go right ahead. The common, now we're just combining like terms. 18 minus 35 becomes -17. And then 42i plus 15i, 42 and 15, 57. Again, we kept the real number in front, the imaginary number in the back, so that's already in standard form. That is done. That is all you can do. The last one, we are taking 3i and we are distributing it to a -2 plus 5i. 3 times -2 is just -6i. 3 times 5, positive 15. I times I is I squared. Good. I squared, again, you replace with a -1. Everything else stays the same. -6i plus 15 times -1 obviously becomes -15. I'm going to put it in front because it's the whole number, or sorry, not a whole number. It is, but putting it in front because it's a real number. And then I'm going to subtract 6i, put it in the back because it's the imaginary part. A plus bi, standard form. All right, so we have added them, or sorry, not there. We have multiplied them, FOILed them, distributed them, subtracted them. Now we are going to talk about fractions. The reason we're going to talk about fractions is because we do not want i's in the denominator, just like we don't like negative exponents. Oh, no, negative exponents are anywhere. Just like we don't like square roots in the denominator, we don't like imaginary numbers in the denominator. So this I we're going to get rid of, this I we're going to get rid of, but this is a bit more complicated to get rid of this one, right? So I'm going to come back. I'm going to come back to page 3 and we're going to do this for a second. We want to take this fraction and put it in a more standard a plus bi form by ensuring that there are no i's in the denominator, no imaginary terms in the denominator. Here we have 3 plus 2i quantity divided by I. If I want to get rid of this denominator, I just multiply. There's no equal sign, right? So I'm not going to multiply just this whole thing by I and over here by I. I have to instead multiply the bottom by I, multiply the top by I. Because I know that I times I becomes -1, and so the i's will be gone, right? Rewrite that again. On the top, I have 3 plus 2i. On the bottom, I have I. I'm going to take both of those, multiply them both by I. If I multiply this, I times I get -1, right? Okay. And guys, if you ever have trouble with Wi-Fi, remember I'm recording this. So you can always go back and watch it if you need to leave. If, don't waste your time. If you are 100% can't keep up because of technology. Here, we're just going to take both terms of the binomial, distribute the I to both of them. Good. So I times I becomes I squared, which we translate to -1. Here I'm going to distribute the I. 3I plus 2I squared, right? Because 3 times I is 3I. 2I times I is 2I squared. I squared becomes -1. So that's -2 plus 3I over -1. Good. I feel like there was something I was going to say, but I forgot. Now anything divided by -1, we're just changing the sign of it, right? -2 divided by -1 just becomes a +2, right? Negative divided by a negative becomes a positive. Positive divided by a negative becomes a negative. I don't remember what I was going to say. All right. So that's our first one. Oh, I was going to say that it is okay to have the I in the numerator. It's not okay to have it in the denominator. So we are done with that first example. Next, we have 2 minus 5I over 3I. The 3 part is okay. It's just the I don't want. So again, I'm going to multiply the top and the bottom only by the I. You can definitely do 3I. It won't be wrong. You'll just get a bigger number. So it won't be in simplest form. So only the part you need gone, and the only part we need out of the denominator is the I. So this becomes 3I squared, because 3I times I is 3I squared. I'm going to distribute this one. I times 2 is 2I. I times a -5I is a -5I squared. My next step is to translate those I squareds into -1s. That I squared can become a -1. That I squared can become a -1. -5 times a -1 is a +5. I'm going to put it in front because it's the real number. I'm going to put the 2I behind it. 3 times -1 is a -3. I cannot simplify this. Here, -2 can be divided by -1. 3 can't be divided by, or sorry, 5 can't be divided by a -3 to make it any simpler. So that's my final answer. It can be written as -5/3 minus 2I over 3, but you don't need to. You just leave it like that. Just saying those are the same value. Last one. So here, sorry, I had to sneeze. Here, here I said we don't need to include the 3, we can just do the I. However, here, I have to sneeze again, 1 second. However, here, these are not being multiplied. So I have to take the entire denominator. That's one part. that you now can't read because my highlighter was too dark. That's one single factor, essentially. Here, the factors were 3 and I because it's 3 times I. There's nothing being multiplied here, so you have to take the entire denominator together. That is why we're going to cover conjugates. A conjugate is an opposite of a binomial. Good? All right. You can't leave a radical in the denominator because that would be an improper fraction. You can't leave an imaginary unit in the denominator either. So we want to divide out the imaginary numbers in denominators. A conjugate is the same binomial. A conjugate of a binomial is that same binomial with the difference being the opposite side between the sign between the two terms. It's a bit like when we were studying last week, a squared minus b squared. The difference of two squares becomes a plus b times a minus b. You have the same terms and you just have a different sign between them. And because everything's the same, you cancel out your middle term. Yeah. You can also call it just changing the sign of the second term. Find the product. Okay, the product of a complex number and its conjugate is a real number. That's the whole reason we have complex conjugates, is so that you can turn a binomial or an imaginary term into a real number. Find the product of the complex number 2 plus 5i and its conjugate. All right. 2 plus 5i, my terms are, like if I was going to say a and b, right? It's essentially what we're doing. We're changing the sign in between the two terms. So here a is 2, b is 5i. So instead of 2i plus 2 plus 5i, the complex conjugate is 2 minus 5i. 2 plus 5i's conjugate is 2 minus 5i. So they want to know what the product is. So then you just factor it. 2 plus 5i times 2 minus 5i. 2 times 2 is 4. 2 times negative 5i is negative 10i. Positive 5i times 2 is positive 10i. Ooh, I'm sorry. 5 times negative 5 is a negative 25i squared. Is that all right? All right, so now we still have 4. The negative 10i and the positive 10i cancel themselves out. Minus 25, that I squared becomes a negative 1, right? So now we have 4 minus 25 times negative 1. Negative 25 times negative 1 becomes a positive 25. Good. And that is just 29. So by employing a conjugate, you can turn an imaginary term into one real number. Again, we'll do 3 minus 7i. So here, the middle term is already negative, so its complex conjugate is going to be a positive 7i. 3 times 3 becomes 9. 3 times 7i becomes 21. 21i. Negative 7 times 3 is minus 21i. Negative 7 times a positive 7 is negative 49i squared. 9 minus 49 times -1 becomes 9 plus 49, which is 58. So we know that now. We want to multiply the top and the bottom by the conjugate of 1 minus I, which is 1 plus I, to the top and to the bottom. Is that okay? So it is 2 plus 3I over 1 minus I times the quantity 1 plus I, 1 plus I. Good. All right, now we're going to FOIL the top and the bottom. 2 times 1 is 2. 2 times I is 2I. 3 times 1 is 3. Sorry, 3I times 1 is 3I. 3 times I is 3I squared over 1 times 1 is 1. These will cancel, but we'll have I minus I minus I squared. Now these become -1. So we can rewrite this as 2 plus 5I plus 3 times -1. Down on the bottom, we have 1 minus -1. Good. All right. 2 plus 5I minus 3 over 2. 1 minus -1 is 2. -1 plus 5 over I over 2. Example 5 just wants us to put the negative square root into terms of I. Okay, so that we know how to translate it so that we can continue working on something that might come out of the quadratic formula. So the square root of -1 is I. Good. The square root of -25, you just want to factor out I. Okay. So the square root of -25 is the square root of -1 and multiplied by the square root of 25, right? Which is the square root of -25 factors to the square root of -1 and the square root of 25. The square root of -1 becomes I. The square root of 25 is 5. So the square root of 25 is, sorry, the square root of -25 is 5I. Good. The square root of -12 is the square root of +12 and the square root of -1, which could also be the square root of 12 becomes the square root of 2 times 2 times 3, right? Oops. Good. So those two 2's come out. 2 square root of 3 times the square root of -1 is I. So we write that as 2I square root of 3. And it's just 5I.